Hey guys, I'm Matthew Johnson. I'm a computer science student in my last semester of the bachelor's degree, actually. And here's kind of my first ever YouTube video that I'm making. There's a chance I might end up making more in the future, just to give some tips about coding that I've learned over the years, especially hopefully helpful to those who are going through the computer science degree right now. The first one I wanted to make is kind of about something that I wish I had honestly known earlier on in my degree, just because of how incredibly useful and used it has been more recently, and that is Git and GitHub. These aren't necessarily coding specific, as in I'm not teaching you how to code in this video. This is more about an incredibly useful tool that could very well end up helping you as you are coding. Well, let's get into it really quick. And just FYI, this is kind of a one take, hopefully it all works well video. So probably gonna be rough, probably gonna be imperfect. Bear with me. And if there's anything that I say that's not correct, technically correct, those of you who are experienced, feel free to throw that in the comments. I'm sure some people will appreciate it. But moving on, let's kind of go into it. So uh, just at the most basic form, Git and GitHub are different things. Git is kind of what everything is based off of in this topic. It's kind of a language or a software that it's a version control system that, in other words, helps you keep track of your code as you're making and saving it. It allows you to um, save a state of your code and switch to having a new state of your code if you wanted to, so that you can have, like, say you have this really cool program that does these really complicated math things, and you decide that you want to add a new feature to it. You could save the working state and then go into what's called a new branch, which has everything you made up till that point, but allows you a place where you can be experimenting and adding new code without necessarily, well, you still have saved elsewhere the working version. So in case something ends up breaking and you have like major problems on this like new branch that you're writing code on, you can easily revert back to that previous state of the code where things were working. I'll kind of show you what that means in an extremely simple example a little bit later on here. But so a base version, Git is a version control system. It lets you keep track of your code and gives you some pretty nifty tools with uh, managing your code overall. And the cool thing about it is it's free and open source. We're able to use it as students, and it's pretty useful. You'll probably end up having at least a couple of teachers that'll have you be using it over the course of your degree. As far as GitHub goes, GitHub is based on Git. It's a web-based platform that utilizes this Git version control system to host code. So you could be making a project on your local computer and everything, but say you want to save that somewhere other than just your computer, you can save that in GitHub. I'll kind of show you what that process looks like, but we'll be making something in GitHub and then bringing it locally. But uh, it's one of the cool uses of GitHub is that you can use it for collaborating. Whether it's a class project you guys have, you can share it between multiple students, and so that then each of you guys can be working on the project, working on different features of it, and have it all come to one place in GitHub where that is stored. When you're using GitHub, one of the terms that you'll end up hearing a lot is repo or repository. That is the name essentially of the container that the code sits in. So you could probably think of it as being similar to a project or an application, sort of, in a way. The repository is just basically where you stick a project that you're working on when it lives in GitHub. So let's get into kind of the first things. I wanted to show in this video just the kind of simple setup process. So if we hop in here, we're gonna start the install for Git. So if you just Google Git, one of the first options, you might have to scroll down past all of the sponsored content that gets thrown all over the place. But we'll find here, I guess this technically works. So you'll find, so long as you look at the link underneath the title, if the link says git-scm.com, That's what we're looking for. Because like if I hover over this link, it's just going to some bing.com thing. So I'm going to see if I can find the link that I actually want. This is taking me right to the install. We'll find, let's just type this into the git-scm.com. That's where we want to go. Okay, and this takes us to Git's website, where we can install it. There's probably a lot of other interesting things you can find, including this pro guide that they have online that you can review for free. But what we're going to be looking at is this install button down here. This will take us to here where you can choose whichever operating system you're working on. I am on Windows, therefore I will go here. And I'm just going to click this first link because this is the one that will download the most recent build of Git. So we're going to get that started. Open that up. Okay, and for this, for the installer, I'm going to mostly stick with default settings. You can definitely, and I encourage you to look up if you have any questions about any of the other options that it gives you to see what they do, just so that you can understand what they do and if you might want a different setup as you're installing it. But for me, for my purposes, sticking with the default is going to be sufficient. So default location for it to be saved, yes. If you know the language Bash, it looks like there's this cool feature where you can add a Bash profile so that in Windows you can have access to some of their really cool commands. So you can add that if you want to, but if you don't know, then you honestly don't have to have it. It's just a fun feature. But we're just going to stick with default here. Hit next. We're going to keep that as well, the defaults. I do want to point this out. There are going to be times when you're doing Git commands and it's going to open up a window where it's going to ask you to include some notes about why you're making those changes or things. When it opens up that window, it's currently setting to default to use the Vim editor, which if you're a Mac or a Linux user, you're probably familiar with this. If you aren't, just know that it's a little bit more of a difficult editor to use. Um, it requires kind of knowing some specific commands and things. So if you're not so familiar with it, you might want to switch it to something like Notepad++ or Visual Studio Code if you have one of those installed. That would kind of be my recommendation. But for my purposes, I'm just going to stick with Vim. I will end up showing you kind of at least how to do some basic stuff with that. But we're going to do that, and then we're going to stick with the default here and here and here. Again, look stuff up if you're interested about what these other options are, but I've found it to be pretty effective just to stick with what it's giving us by default. So we're going to start that upload. Okay, so it's currently working on installing Git now. While it's working on that, I'm going to go and switch over to showing you a little bit about GitHub now. Again, just to emphasize, Git is what I'm installing on the computer that will allow me to have version control on my computer. GitHub is the web-based thing that runs with GitHub, with Git. So if you go to github.com, this is where you're going to land. Though they might end up making this look different as they change things over time. So this might end up being outdated at some point, possibly when you're watching this. But if we go over here, um, you can click sign in or sign up. If you click sign in and you don't have an account, then it'll still give you this option to create an account. Um, and when you click on that, it's a pretty simple process. You can either link it to a Google or Apple account or just put it in email, make your own password and username, and you can go along through that process. It's pretty simple. I already have an account, and I'm going to, I tied it to my Google account, as you see here that I have open right here. Don't need that, but just needed to sign into it. But anyways, I'm gonna continue with Google, and that's how I'm gonna be signing in here. It makes it nice and quick. Awesome. So this is the landing page. I'm going to, I guess first, up here, you'll usually see on the left hand a list of repositories that you've been shared or given access to or you've created. And currently I just have one called Simple Math. I'm going to make a new repository just to kind of demonstrate what that looks like. So we're going to click the new button. And first we get the option to name it. We're just going to call it test repository. And just give it a short little description. Awesome. So next, an option that you have is choosing whether or not to make your repository public or private. Public meaning that anyone on the internet can access it, whereas private is just something that you and others that you specifically give access to will be able to work on. Um, I'm going to choose private, and for the most part, if you're starting out with things, you're probably going to end up making private repositories, especially when you're doing assignments and things, and then you can share those with your teachers or set them to be collaborators on the project. But anyway, so I'm going to set this to private. And I'm going to go through a couple of these really simply and just quickly right here, and then you can look up more about these if you want. But a README file that it's offering to generate, if we click to this check button, is a file that gives some basic information about what the purpose of your repository or your project is. This would be somewhere where you can put some basic information about what the repository is for, how to maybe install and run it if it's got some special things that need to be set up, as well as explain kind of the general layout of the project and maybe certain features that it has. There's a lot that you can stick into the README file, and you'll probably notice this if you go find other public repositories. As you know, as you get farther into your degree, you'll probably have plenty of opportunities where you'll be directed to other people's repos. Um, I'm not going to include a README file in this. The other thing it lets you add is this git ignore file. That is a special file where you can stick folder names or file extensions, things that you don't want to be uploaded to GitHub when you're making those things locally. So say I have a project that I'm working on that makes these super fun and complicated math equations, and I go to have my code editor like compile my code and make it runnable. It's probably going to end up generating some temporary files, and I don't necessarily want those temporary files to be uploaded to GitHub because they're not an actual part of the project itself. They're just something my computer needed to make. So that's kind of one example of some things that you might want to have git ignore include. And you can look up more information about how to use git ignore and what to type to get it to look at certain files or folders to ignore them. That could also be a place where you have it ignore certain folders, like a folder that has just your personal notes in it that you don't want uploaded to GitHub, but are just notes for you as you're developing, things like that. And then you can also look up information about what the different licenses are and why you might use a particular one. It's kind of like your Creative Commons in a way, but just kind of possibly a way of demonstrating what the purpose of your project is. We're just going to stick with no license though for this one, and then we're going to click Create the repository. Okay, and we're going to talk about kind of what it's showing here in just a second, but it looks like we finished our Git install. Yep, so I'm going to click the Finish in here. And now to demonstrate that we finished installing Git, oh, and it's going to open a tab for us saying it was so happy it installed. Here's some release notes. We don't need those, so we're going to close them. Okay. Yep, it's being a little bit slow to load. Okay, well, I'm going to type CMD, or you can type command prompt. Typing either one of those will get you to see this command prompt. If you're in Windows, if you're on a Linux or Mac, it'll be called terminal. Sorry, yeah, this video is going to be pretty Windows heavy, but CMD or command prompt brings up this little guy that we're going to open up. This is where we're going to be doing a little bit, the bulk of our Git demonstration, besides like making some files, which will be in the Notepad++ that I downloaded. Anyways, so when you open up a command prompt, you can now type git, and you have a bunch of options for things that you can use with it. I'm going to show you a couple of like the most fundamental ones, and then you can do research on the other ones as you go and as you want to experiment. But for now, at least, if you type git version, this is another way. Oh, sorry, let's first clear this so you can just see what git version gives us. This is like the easiest way to test that git installed correctly. If it actually gives you a version here, that means it works. If it says that it doesn't recognize git as a command, that means that something didn't work in the installation process. Or if you happen to have this guy open before you installed him, you actually need to close it and reopen it so it actually picks up that you installed git in the first place. But looks like we have what we're looking for here with the git version. So now we're ready to start working on things. If we switch over here now to our test repository we just created, you'll notice here that it's giving us some quick setup information. saying, hey, you got an empty repository. Here's what you can do to get this set up on your local computer now. Because currently, we've made something in GitHub or in the cloud, but we don't yet have this repo or this project on my computer yet. So there's a couple of options here. You can install a GitHub desktop, which is an application that probably looks a little friendlier and isn't necessarily command line stuff. So you can use that if you would like to or experiment with it, but I'm going to stick with the command prompt, so we're going to stick with this guy. We're going to use just the link here. SSH is something that if you set up a certain token on your computer, you can use that, and it does help with speeding up the process of getting the repository locally, but it does take a little bit of setup work once to get that SSH set up to be able to be used. And you can do some research on exactly what that requires. You can just Google how do you set up how can you clone using SSH, or what do you have to set up to do that. But for now, we're just going to stick with HTTPS. So we're going to copy this link, and then what we can do on our in our command line is we're going to type git clone and then paste in that link that we have, which is if you hit Control V after copying, that's how you paste it. Git clone basically is just saying that we're going to clone the repository, we're going to copy it from where it is in GitHub, and we're going to put it onto our computer. And the thing to note is it's currently going to stick it right in the folder that I'm currently in, which is the C drive /users/ and this is the name of the user. I'm using a sandbox account, that's why it looks weird. So it's going to make the folder right in there. If you'd like this folder to be somewhere else, you can you can navigate to that folder before calling git clone. So hopefully you know what those commands are. If you don't, you can look up what are basic command prompts commands that you can use to navigate folders and things, and Google can help you out there. But anyways, we're going to do git clone, and we're going to use this link. And we hit enter. Let's see if it works. I think it's just thinking. Nope, it's not. Let's try that again then. Nope, it didn't paste the link in. Again, you get the uncut version. Future videos might look friendlier than this, but anyways, so git clone, and then the repository, hit enter. Here we go, saying that it's cloning. That's just from a previous command that we typed. So there's a chance that it's going to say it's not going to work just yet because you have to set a couple of other things up. That's where the SSH ends up being a simpler option than this one, but let's give it a second to try it first. Okay, yep, that's what I thought. So I just waited a second, and then we got this little window popping up saying connect to GitHub. In order for it to be able to actually go and clone that repository, it wants us to sign in first. So there are a couple of other options you can set up, like signing in with the code or a token. For me, I'm going to use the sign in with your browser because that's kind of the simplest one because I haven't set anything up. So it's going to redirect me to the browser. And because I'm already logged in to GitHub, it's going to work. If you didn't happen to be logged into GitHub, whether it opened up a different browser or you got the cloning link but you weren't logged into GitHub, maybe you got the link from an email or something, then you'll just need to make sure that you're logged into your GitHub account, and it might probably put you through that process when it opens up the window. Because I was already logged in, it did that automatically. And so then it says, please complete your authentication. Then it says, warning, you appear to have cloned an empty repository. This only happens if you didn't have any README in the repository or anything when you originally got it. It's not really a problem though, it's not an issue. So now that we have the repository locally, if I do dir, which lists out the files in my directory that I'm currently in, now we have a new folder called test repository, which means that when it cloned it, it created a folder for the repository on my computer. And if we open File Explorer, and it thinks for a second, we'll go to this PC, into the C drive, into users, and if you're wondering how I'm doing this, it's just off of the command prompt that mysteriously closed. Or did I close it? I might have closed it. I closed it, yep. Anyways, but if you're wondering how I was finding that, it's because we know we're in the C drive, we know we're in users, and then we're in that user, which is this guy. Yep, and here we go. So, and then if you look here, we've got test repository, which is just barely added at 518. And that's the repository that we just cloned locally. So now we have access to it down here, and we can do stuff inside it. So, for instance, if I wanted to, I could go in here and then right-click, new. It's not giving me the option to do a new file, and that's just because Sandbox doesn't give me a ton of options for already installed things. So what we're going to do is I'm going to use the editor that I downloaded, which is Notepad++. You could install Notepad++ if you want, just by going to their website, or if you're planning on doing coding, if you're in school, your teacher's probably going to give you a specific editor they want you to use. Visual Studio Code's a popular one. I personally enjoy the ThinkBrain company's things. Like currently I'm using IntelliJ a lot, but um, whatever floats your boat for your code editor, or you could just have a simple notepad if you're making a text files anyways. So for this one, we're just gonna do something simple. We're just gonna say this is a note. Again, not really demonstrating code in this, just kind of demonstrating how you can use cool tools like GitHub. So, and the purpose of this is to be for people, especially who may be new to coding. If you know how to code, then you can pretty easily know how to apply this to your scenarios. Basically, you make a file, and we're going to hit Control S, which is to save it. And when we get this guy pulled up, we're going to see that it's giving me an option of where I want to save it. I'm going to go navigate to that folder, test repository, and we want to save it inside of here. We'll just do note.txt. Okay, so now I've got the file saved. And so another command, so far we've learned git version and git clone. If you do git status, this will help you find out where your project is at, if anything has changed since you either most recently got the project or since the last time you saved changes. But you'll notice not a Git repository. It's because I'm not actually inside the folder that's the repository. So if I do cd and then test repository, this is what cd allows me to change directory or go into this folder. So now that I have that, if I hit the up arrow, I can go back a couple commands. Now we can do git status, and now we actually get some more information. So let me clear up my screen and then we'll do that command again. Okay, so first of all, you'll note that it says on branch main. I'm going to describe what that is in just a second. It says we have no commits yet, so there's nothing that is ready, nothing that has been staged and ready to be sent to GitHub just yet. And sometimes when you do these commands, it'll give you helpful information about what the next step probably is. Like right here, it says nothing added to commits, but untracked files present. And it says here the untracked file is note.txt. So then it says use git add to track. So the first step is now that we've made a change or we've made a file, the next step in saving that to GitHub is we want to add it to the files that are being tracked by Git. And it'll say, hey, if there's ever changes made in this, or changes have been made, we're going to keep track of that in our current commit, which a commit is you've made changes. This is just kind of the history of those changes that you're ready to send somewhere. So we're going to add note.txt. That's one way that you can add the file. If you wanted to add all files that currently have been changed, you could just use a dot. But for this, we're just going to do add note.txt. Cool. So now if we do git status, we're going to see that now it's tracking the file and it says changes to be committed. So next we're going to do git commit, And then dash M means we're going to add a message on the end, and then you do double quotes. We're going to say add a new note file. Usually people will keep this statement brief, and it'll be something that they'll say in present tense, something that you're wanting to do, you're adding, so add, and then kind of the information about what it is. Just something that explains what this most recent change is. And this isn't necessarily just the fact that you changed one file. What typically you'll do is you'll want to add a new feature to your code or fix an issue that you just discovered or something. And so you might end up making changes to multiple files, and then you'll add all those files and then you'll commit them as a logical chunk of work that typically either adds a feature or fixes a problem. And this has been something that's been super useful to me because just having this method of breaking things into logical chunks has helped me pace myself with coding and code in more logical ways. Because sometimes you're going to get assignments where you're going to have to do a lot of changes in a lot of things. But rather than trying to just do them all at once and keep track of everything as you're going, that can be a little confusing and difficult over time. I have found that it is far more useful to say, here's this overall project, here are my goals for what I need to do. How can I break this into smaller pieces and do one at a time to get, like the minimal functioning piece that I need? Sorry, I don't have a great example off the top of my head for that. Hopefully in like a future video or maybe a future version of this video, I'll have that a little bit more refined. But it's like, if you're wanting to make a new math function, maybe you just add the basic code for that math function. But even if the function doesn't do anything yet, you kind of make the scaffolding for it first. And then you add it and you commit that. And then maybe in the next commit that you do, you're going to add the actual functionality to it. And maybe you'll add some test cases to see if it works. And after adding some code and tweaking some things, then you'll commit that and push it. But then maybe say that there was an issue you discovered, then in the next commit, you can go through whatever files were made in that project and fix whatever you need to, and then you can add and commit those, if that makes sense. And I'm sure there's plenty of other videos that can kind of describe this process as well. But anyways, so git commit dash m, we're adding a message, and then add a short simple thing, and then we'll hit enter. And then we get to our next issue. So this will probably be only appear once when you're first doing this. This is just when we're setting this up, it doesn't know who we are. And so part of the reason why I think it needs this is so that it can describe when this information appears in GitHub, who exactly did something to the code. So it's even being helpful in telling us exactly what we need to run. So I'm just going to copy, starting with the first letter here. We're just going to copy that first message, and then we're going to replace the email with my email, which is this guy. Here, let me expand my window so we don't have it going over the edge like that. Okay. And then the second one it wants us to run is this guy. If I hit the up arrow, then I can just backspace it back a little bit, and then just replace the email with .name. And then this is just so you can put in your name. I don't think it has to necessarily be your username. You could probably make it that if you want to. So I'll put that in there, and boom. So now, so most recently what I did is we typed the commit -m, we added our commit message, and then it wanted us to run these two commands, and it looks like it did that successfully. So now, if we hit the up arrow a couple times, we'll go back to that, and if we do this again, and we scroll down because it keeps scrolling us up every time we do that. This is the most recent thing we did. We reran this, then it says one file changed, one insertion, and it created that. Cool. So now if we do git status, let's do this really quickly. CLS clears your screen. Okay, so now if we do git status one more time, it'll say, okay, we're on our main branch. A branch is based on origin/main, origin meaning in GitHub, and main being the name of the branch, which again I'll describe in a second. So it says, but upstream is gone. Use git branch unset upstream to fix up. That's not necessarily a concern. I think we're going to end up fixing that with this next step anyways. So when the last thing that we're going to do is git push. So to recap really quickly, once you've made the changes that you want to make and you're ready to send your code to GitHub, you're going to first do git add and then the name of your files that you're wanting to add. Wow, I can spell. Promise I can spell. Um, so first, you add the files that you want to track. Then you commit them with a short message. Then, once they're committed, oh, that's not what I wanted. Once they've been added, then the last thing you do that actually sends that commit to GitHub is just push. If we do this, it's not going to quite work the first time. Or it is. Nice. Oh, that's right, I'm thinking of something else. Yeah, okay, so I'll show you that in a second. But git push, and then it sends the code. So, where before it was showing this page, if we refresh now it looks different. This is what you're going to more commonly see when you have a repository that actually has information. Up here we have a couple of tabs like code and a bunch of other things you're going to end up learning along the way as you get deeper into coding and computer science. But right here we have this thing that talks about branches, and again I'm going to go over those in just a second. But then here's the bulk of where it'll show where your code is. And right now we just have node.txt. And if we click on it, then it'll show us the entire file, all 15 bytes of it. But now we can close that out for a second. So that's the basics of making changes, and then you make those changes on your computer, and then that's the steps to send that to GitHub. And I guess I'll just put that over here. So git add name of file, git commit dash m short message about changes, and then git push. Those are your most basic commands to stage the changes that you've made on your local computer, include them in a commit, and then push that commit to GitHub. The commit is just kind of like you could almost call it like a journal of the changes that you've made, except that that journal is kind of part of the actual code itself. So it's like, say an inventor could make their creations like a flying machine and a submarine and things, and then after he's designed the machines, he can somehow store them in this magical book that he can send places, and people can pull those inventions out of the book. Maybe that's a terrible explanation, but in that sort of way, a commit is where you're taking all of these changes in a logical chunk, and then you're storing them in GitHub and on your computer. So then you can look back through your history, and there's actually ways that you can look back at specific commits where certain changes were made. So next, the one other thing that I kind of wanted to emphasize, hopefully in this not terribly long video, is about something called branches. And for an explanation about this really quickly, we're currently, it keeps saying this word main here, and if we do git status, it's showing us we're on branch main. Branches are kind of ways that you can have different versions of your project at a time. And the reason why we would want to have different versions is because, say I have a project that's working well, like I have an application that can do these complicated math functions, and I've polished it up, it's working, it's great, and other people are using it. I have to have one version that has that working code, but I also want to be able to work with that code. And if I have other people that are going to be working on the same project, I want them to be able to work on it too, and see those changes. And so that's where GitHub comes in. But we currently only have one place that our code is stored, and any changes I make here are going to be sent just to this one area, right? This repository. But what happens if I want to have kind of a place to work with the code, a place where I'm working on things and things might be broken, things might have errors, it might not be complete yet, but I can send that code up if I need to and other people can work on it without impacting the currently working code. In that case, we can use branches. So main is kind of the core branch, the initial branch that's created that has the current code, and typically people have main be the branch where the working code lives. So then you can check out a new branch to go work on other codes. So really quickly, git checkout -b is the command that allows you to create a new branch to work on. And we're going to call this branch name add, let's see. One of the biggest problems you'll discover in coding is naming things. It's kind of one of the biggest issues programmers come across that we've agreed on is one of the hardest things to do is just figuring out what to name stuff. Add text. So let's say I'm wanting to have this new branch where the whole thing that I'm going to be doing for this project is I'm going to add this fancy new thing called more text. So then if we hit enter, it not only creates that branch, but now it switches to that branch. So now I'm on this add text branch. So another command you can use, so that's git checkout is how you make the branch. But if we do git branch now, this will tell us what branches exist on our computer and which one we're currently on. And it'll mark that one with a star and typically some coloring. And so we were on main before, but now we're on add text. So if I go back here to the notepad, you'll notice that everything looks the same still. Nothing has changed so far. We still have just this one file. If I go into the File Explorer, we'll see that as well. I really need to stop closing windows before I'm done with them. Okay, test repository. And we see that in this new branch, we still have note.txt. Basically, you can kind of imagine this, that each branch kind of saves. When you make a new branch, you get all of the code that was on the previous branch you were just barely on, and it's almost like it's copied over to this one in a way. It probably looks different under the hood, but just kind of from a basic understanding, that's kind of what it's doing, is it's just copying the branch so that you can work on it in a new space while the other branch is left untouched. For instance, if I were to go in here now and add a couple lines and say, just add some letters like that, and then I'll save my file. If I go in here and go through our steps of adding things, so, well, let's size these so you can see both of them. So if we add, well, if we look at this really quickly, let's start with doing the status. If we do git status, we see we're on branch, and then it'll give us the branch name, and it says we have some changes that have not been staged yet. So we need to add that one. So we're going to do git add note.txt. We'll add our message. Okay, and so then we'll push. This time it's going to fail. And the reason why is because we've made this branch locally, but it doesn't exist in GitHub yet. So it's like, well, where do you want to send this branch in GitHub? Because we don't have a home for it just yet. Because if we go in here, and this is our branch symbol here, but then if we click the drop down, this is the list of all of our branches, just main. So it doesn't exist there yet. Thankfully, it gives us some, and that's what it means by no upstream branch. Upstream means in GitHub. If you see the word upstream, that's typically what it's referring to, and or remote. So it says to push the current branch and set the remote as upstream, use this command. And this is exactly what you're probably going to end up doing most of the time. So we're just going to type this. Just like so. And if we scroll down so that you see actually what we did, so we just typed that command and then it's saying, got some things, and it looks like it's good. Okay, so now if we go in here, we see that some things just barely appeared. I'm going to kind of explain what this is, but this just popped up. But if I click the drop down, maybe I need to hit the refresh button for it to see it. If I hit the drop down, now we see that there's an additional branch called add text. So if we're going to show this first from the local perspective. So if we go back down here, so we're currently on the add text branch. And this is the file that we added, and we added this extra text onto the very end of the file. If I want to switch back to my main branch really quickly, because I want to show you guys that nothing has changed on the main, even though we changed something on the add text branch. If I want to go back, I just do git checkout, but instead of -b, because that's what creates a new branch, we're going to do the name of the branch we want to go to, which in this case is main. You're only going to be able to check out a branch if you've committed all of the changes that you currently have on our branch. So say I add some extra changes to this file and save them really quick and then try to move to a different branch, it's going to have issues with that. But since I've committed and pushed my changes, technically you just need to commit the changes. But since I've committed and pushed them, I can do this command where I can do git checkout main. And now it says that we switch back to main. So if I do git branch, we see that we're now on the main branch. And if I click in here, it's going to say the file has changed. If you're using a different editor, it might just automatically reload the file based on the changes. But for Notepad++, it's going to give me this pop-up. So I'm going to hit yes, I want to reload it. And you'll notice that text is gone that I added. This is because I went to a new branch or a new kind of a new, you could almost call it like a new timeline from like a zoomed out perspective of coding. It's almost like you're making a new branch of time that you're making changes to that's completely separate from the main one. So when we make those changes and we push them, they're still going to be on that branch. And if you go to the other branch, it's untouched. It still has whatever your previous code was. So say this project had all the working code, it is untouched now, and I have a different place where I've got whatever I'm working on. Typical use cases for branches are when you're adding new features or fixing issues. Say I have main and I have my fancy math programs, and I want to add a new program to take the factorial of something. I can create a new branch called add factorial, and on that new branch, create the code to actually do that. And then I still have the working version in main. One reason that's super useful, and this is one of the biggest reasons why I wish I knew this when I was way earlier on in the degree, was because if you are so far into coding on the new feature you're trying to add that you can't just hit the undo button to go back to the working version, it's really nice to have a way to go back to that previous version. And if you've made a new branch that you're adding the feature on and then it just suddenly breaks, then you can easily just check out the original branch you had and then just go and make a new branch off of it to add more code, if that makes sense. So say I didn't like the fact that I added the ABCs on the end of this, I can revert back to main, and then I can just do git branch or git checkout dash B, and then I can have a new branch that I can check out that's based off of main that has the original working code, whereas I still have, whatever the other branch is on the side, if that makes sense. So that's one of the super helpful reasons. But what if I'm happy with what I've got on the other branch and I want to have my main branch get those updates? I want it to have those changes that I've made so that those can be included. The way that we would do that, so I need to, let's see, git branch. Currently we're on just that temporary one that I just already made. We're going to go back to main. And there are a couple of ways that you can get the changes from one branch onto another. One of them is using git merge. Another one is using git pull -- rebase. And another one is doing something called a pull request. I'm not going to show what this one is. It can sometimes be a more risky one, and this is one that you can either research to understand later or that you might end up learning much, much later in the degree. This one is the one that I'm going to demonstrate right now, though, and then I'm going to show that one in a second as well. So um, the way that the way that I'm going to show you how this works, and if you ever wanted to know what something does, you can also have the command and then type -- help at the end. So if I want to know what git merge does, I can do git merge -- help. And if I hit enter, for me, this is going to open a window in the browser. Maybe. There we go. I'm working in a sandbox, so things load slowly. So it's going to pull up this page that's going to give information. The way that I have things set up, it's opening in the browser. You may end up just having it appear in the command prompt still. But the one thing I want to point out here that's cool about this is in the description, it's going to give us a bit of a visual look of what branches look like. So say your branch is originally created and has some code on it, and then the code is at state E, where you maybe have made some changes, you have a couple of files, and then you want a topic branch, or this could be a feature branch, something where you're adding new code. You can create a separate branch, and maybe it's got some things going on, but say somebody else is also working on the code and they make some more changes to master in the meantime, then you kind of have the state where you've got a master branch. Master and main are kind of synonymous names. Master is kind of the old way of calling the core branch that the code has, whereas main is the newer naming that people are using for it. But say we're finished with our topic branch. We've made all the changes we want to. It's all working. It's awesome. And we want to reconnect it back. We want master to have all of that code that we made. We don't have to go and copy and paste it. And it would be a little bit difficult to actually copy and paste between branches because you're usually only on one branch at a time on your computer. That's kind of the way that Git is set up to be. So the way that you'd do this is you'd use git merge, and what that does is it will essentially replay the changes, or it'll take all of the changes that you've done, and it will stick those onto the master's history. And so it'll say, all those changes that you made have now been made to master as well. And it kind of adds that to the history behind the scenes. So it's a demonstration of that. Oh, and the way that you want to do this is you're doing it from the perspective of the branch that's going to be receiving it. So in this case, when it's explaining the example, it's saying the current branch is master. So when you're merging, in this case, we're on the master branch, and then we do git merge, and then the name of the branch that we're going to be receiving the changes from. So in this case, we are on the main branch. Okay, so we're gonna just clear that and we're gonna pull it up again, so that's just at the top here. So we're on the main branch and we want to receive the changes that happened from the add text branch. So then what I'm gonna type is git merge and then the name of the branch. In this case, it is add text. And now if I hit enter, it's gonna merge the changes in. So now if I open up Notepad++, and I click on the note.txt file, it's going to say, oh, it's been modified. Do you want to reload it? And if we hit yes, now we have the most recent changes. But if we go into GitHub and we hit refresh, and it refreshes, okay. But if we hit refresh, if we click on note.txt and we're looking at the main branch, it still only has this. One way that we can get this to update with the code is now that our main branch is updated locally, we could just do a git push to send all of those commits that were just added up to GitHub. If we did git status, you'll see that it's going to describe that our branch is ahead of it by one commit, meaning that we have one commit locally that the branch in GitHub doesn't have. So if we wanted, we could just push it from here, but I'm going to show you the other way that we can take changes from one branch and apply them to another one in a pull request. This is something that is industry standard. This is what people in jobs do when they have code, because typically you're not going to be the only one working on a project. You're going to be working with other people. And it's always best practice to have more than one set of eyes on a particular project. I know you may be perfect at coding, but it's helpful to have somebody else review it just to make sure things look good before it gets added into the working project. And so the way that they do that is typically you'll get a notification at the top here that says that there was a recent push to a branch, and you can compare and pull requests. So I could just click this button and it'll start to do the pull request already, but you can also click on this pull requests tab up here, and then you also have the option to just add a new pull request. So we're going to just do that for this one. So if I click this, then we're going to get this tab right here where it says the base and the compare. Base is going to be the branch that's going to receive the changes. So it is going to be what gets those new commits in and updates it. So we're going to leave that as main. And then the one that we're comparing it to, or the one that we want to get changes from, in this case, is the add text branch. What it's going to do is it's going to check to see, is it able to merge? Most of the time, it will. But what happens if I happen to make a change to line 6 of this file, and somebody else on a different branch already made a change to line 6, and they've merged that change in? GitHub might not know which change to keep and which one to get rid of or overwrite, and in that case, you'll have a merge conflict that you will have to resolve. And that is something that I could possibly make a video on in the future, or you could probably find online. There's probably plenty of videos on it that describe how to handle those merge conflicts. But for this case, it's a really simple change. It's very obvious, and GitHub knows kind of what it needs to do to make that change. So it's going to say, hey, can be automatically merged. So then what I can do is I can click create pull request now that I know that I have the branch that I want it to be, that I want updated, and the branch that we're getting the update from. And then we can either leave this title. This is the title of the commit that was most recently done, but we can change that as we want to. And we can even add more of a description explaining what changes did I make? Why did I make those changes? And maybe even list potential issues or other necessary things to know about what changes were just made. But then you can click create pull request. And so now you'll see we have a number 1 up here that says that we have 1 pull request. And if we open that really quickly to see what it's showing here, we'll see you'll sometimes have a list if there happen to be multiple pull requests that are being waited to be reviewed. But in this case, we just have the 1. And if we click that, it'll just take us to what we have right here. But it'll have whatever the description and the title is right up here. And then it'll also list your commits. So currently we only have 1 commit, so it's only just showing the 1 here. And then it'll say whether or not there's conflicts. There's a lot of other things that can be added, so it might have some other messages. There might be tests that it runs and stuff. And you can also request other people to review it. And what other people can do, or if you were reviewing somebody else's pull request, you would find the pull request in this tab. You'd click on it. And then what you can do is you can click on Files Changed to see what files were updated and modified. In this case, we just have the 1, so it's just showing it up here. Red shows what text was removed, and green shows what text is added. And I'd say, well, yep, I reviewed the code. It looks great. You could say approve, but I can't really approve my own code. That's kind of how it works. You have to approve other people's, but you can't approve your own. But anyways, we'll say looks great. And then if we submit the review, then it's going to take us back to the pull request, and it's going to put in those comments. People can put in comments to say it looks good and it's ready to be for the pull request to be merged, or they might say that there's code that needs to be changed or updated or modified and you need to go back. And sometimes they can even annotate the code so you can go back under the Files Change tab and see where they're specifically putting comments about how certain things might need to be changed. But once they're all accepted, we can use this merge pull request. There are other options Those ones are a little bit more risky, and you want to be very sure about why you're doing those. So you want to research those and see what they're doing. But for the vast majority of cases, you're going to just want to stick with creating a merge commit like this one. So we'll click the merge pull request. And then if we wanted to add any final notes as we're merging, we could here. And then we click confirm merge. And then it's finished. If we wanted to, and if you're working in like a live product, like this is an application that is being actively used and other people are seeing and other people are working on it, like this is in an organization or something, it's good to keep things clean and to delete the branch afterwards. Because the way you should look at it when you're coding, a branch is really just for a feature or an error fix or something small and simple. And so you only want it to be focused on that one thing, and then once you're finished with it, then you delete the branch so that it's cleared out, and then if you need to make any further changes, you just make a new branch and you work off of that. But now that we've merged it, if we go back to code here, and we click on note.txt, sure enough, we now have the changes. So this is a really quick, more or less, overview of GitHub and Git and why they are so useful. Just kind of as an overview, I wish I knew this earlier because this would have helped me with coding, especially as projects got larger and more complex. You're going to have some teachers that are going to have you use this. So having some practice with it beforehand will be super useful. But even if it weren't for teachers requiring it, I would have used this a ton when I was working on projects and assignments. Because what I would do is I would say, okay, well, the teacher needs me to make, first of all, a simple program that can just say hello world and send that to the console. And so then maybe I can type out that code and add it and commit it and then push that. And then maybe the next step in the assignment is to add several more like print out statements that print more things out to the console, or things get more complicated and I need to make more changes, or maybe I'm unsure about how to do a certain change and I want to try out one idea that I have. I can make a new branch, and on that new branch, I can try out that idea to see if it works or not. And if it's just a terrible idea and it's not going to go anywhere, I can easily go back to that other branch and still have all of the working code. But then if you're working on class assignments, this is how you guys collaborate. Someone makes a repository, and then you just share the repository with other people. You can do that if you go into settings under collaborators. All you have to do is just add people. You just put in their username or the email, and you can add them to the repo, and they'll get an email about it. But then each of you guys can clone it locally, and then best practices, once you get it on your machine, you make a new branch so you guys aren't coding on top of each other. It's a terrible idea for everybody to be working on the main branch because you could have all sorts of issues. So what you would do is you would first get the code locally, then you'd make your own branch to make your changes on, and then once you're finished with that, then you can send those, you can push the branch up, and other people can see that branch if they wanted to, but then when you know that things are working, then you can have that merged in with main. Either if you're working with a team through a pull request, or you can just merge it if it's just something that you're just personally working on. But those are kind of the basics. There might be other videos or other tutorials out there that could explain more about certain features. Like I said, this is hopefully just supposed to be a simple, small thing going over some of the basics. But one of the things I want to emphasize is the mindset that this brings of how to take projects into more bite-sized pieces of steps. Work on a little part at a time and not just tackle the entire project at once. That's what the branches and the commits can be super useful for, because then you can have them in logical chunks, both in the actual history when you look at it, and also just so that you're not overwhelming yourself when you're coding along the way. Sorry, that was a little bit more long-winded than I thought, but hopefully that made sense. Definitely post any comments or questions if you have any. But thanks for sticking with me. Hope you have a great day. Bye.